Okay, the second section of chapter 3, we're adding and subtracting decimals. Really, there is only one rule that you have to remember when adding and subtracting decimals, and you have learned it before. And that rule is, you must. Good job. Didn't hear everyone, but some superstars said, line up your decimals. Must you line up your decimals with multiplication and division? No, you don't have to. So we're going to get there later. As I've said before, addition and subtraction is often a little trickier in all areas in math and algebra. You know, it's interesting. But we need to line up the decimals. So if we're not adding them horizontally straight across, some students are able to start to do that at your age. But we can just stack these vertically, right? So we can put 5.91 in the first place plus 1.8. And so what might a student do to this number, because it looks a little different than the number above it? Put that 0 in that place value there. So now that they're the same length, and that feels more comfortable to most people. The number 4 doesn't even show a decimal. So where is the decimal for number 4?
0.
Right behind it. Every number that's a integer has that invisible decimal sitting there. So we can place it, and what number can come behind that 0? 0, and we could even fill 2 if we needed it. So by making them all the same length, people sometimes feel that that's more comfortable. Do you have to show zeros there? No, but do you have to line up the decimals? Yes. Okay. And so then you simply add the way you've always added. And so what is 9 plus 8?
17.
Carry the 1. We bring our decimals straight down. And we have 11. 11.71. Good job. Okay? And of course, this is 7th grade, so it's not just going to be adding things like this. It will be adding what's?
Opposite.
Negatives. Lots of negatives. So we'll have to practice what we know about adding positives and negatives, or negatives and negatives. You're good at positives and positives already, right? So go ahead and try this. Okay? Okay, so for this one, once again, you can line up the decimals. And what did you do to find this difference here? Well,
I added.
did you? Okay. Now, in algebra, we really don't subtract anymore. We just add terms together. So in this case, we have a positive term, 25 7/7, and we have a negative term, right? And so we could say that we are adding them together if we change our subtraction to adding the opposite, right? So when we have a positive and a negative, what is the operation we really use?
Subtraction.
Subtraction, right. A positive and a negative. The operation we're going to use is really subtraction. And so, let's see, who has your answer already? 3, 2, and 1.
10.17.
Okay. Good job. And it's positive. Good. Okay, here we go. Let's try a couple more. I'll have a couple volunteers come up and show us these. And look at all the negatives. So let's apply our rules for negatives if you're coming up here, all right? Show us how you add the opposite. Okay, Gabriel will do number C, or problem C. And who hasn't been up here lately, honestly? Okay, Izzy can do D. And I'm going to pause the video and we'll show you what happened. Okay, tell us why you added these.
These are both negatives, and then can't change it to the opposite because since it's addition. Nice
Added them because they had the same sign. Good job. Negative 67. And D. Okay, so Izzy, because these were a positive and a negative, you decided to use what operation? Subtraction. But you had to move the larger number on top and subtract the smaller absolute value. And the answer is 7.27. Good job. Okay, so you're going to try these right now on your own, and then we'll check it together. Okay, so there you go. We have Colin's work. Very nice. Addition of 2 positives. We have Jake's work, which ended up being addition of 2 negatives. And we have Audrey adding a negative and a positive. Okay. The other thing we're going to be doing today is evaluating algebraic expressions, which simply means to find the what? The word evaluate means find the value. Okay, you don't have to write this down right now. You can just look up here. This is just an example from section 3.2 in your textbook. Okay? The Kelvin scale for temperature is used by chemists and lots of scientists because it has a lot of gradations, you know, a lot of lines between the degrees, basically. It's a very fine scale as compared to Celsius, where, what is the freezing point of Celsius? Who knows it? The freezing point of Celsius, Olivia? 0. And the boiling point of Celsius? 100. Do you see how easy that is? 0 is freezing, boiling is 100. But Fahrenheit, which we use a lot around here, when we say it's a 72-degree day, we're using the Fahrenheit scale. That has more degrees in it than the Celsius. And freezing in Fahrenheit, do you know what that is, Spencer? I mean, Stuart? 32 degrees is freezing instead of 0, right? And boiling is, you know, sir? More than 100? More than 200? Gavin? 212. So there's a lot of degrees. Well, Kelvin has even more. Kelvin has got more variation in the degrees. So it's a very fine scale. So the formula for Kelvin is if you know your Celsius, like if we know that the boiling point in Celsius is 100, you plug that degree into this formula here, and you can now find the boiling point in Kelvin. So let's say that boiling point in Kelvin together. If we know that Celsius boiling is 100, then the Kelvin boiling is?
373.
Say it, Alex? 373.15. You're adding 100, right? And if we know that the freezing point in Celsius is 0, then what is the freezing point in Kelvin?
273.15.
It is 273.15. Just, you know what that means? That there's not a different gradation, actually. It has the same number of degrees, but it's like the whole scale has been boosted up. I'm sorry for saying that. It's just boosted up to a higher number. 273 is the freezing point in Kelvin. Interesting. Okay, so if a block of dry ice has a surface temperature of negative 78.5 degrees, dry ice, then what is the temperature in kelvins? Everyone put that down on your paper. Find the temperature of this surface of dry ice in Kelvin. Okay, good. So you subtract the Celsius degrees, and the answer is the 194.65 degrees Kelvin. Very good. So dry ice is super cold, isn't it? Super cold, which is why it's kind of dangerous to touch it. It can burn your skin, actually. It's that cold. Okay, front-end estimation is a way that we can look at the biggest place values in a number. So what is the biggest place value in, how about this? What is the biggest place value in this number here? Jake? The 2, and it represents what place value? Actually, say that number there. It says 240. So it says hundreds, right? It represents a hundreds place. So if we were going to make a quick estimate, what's that number worth? We could say it's like 200 something, right? I mean, we would focus on the left side of the number. That's considered the front end of the number, the left side. Okay? If we want to add numbers quickly, the most important place value to look at is the furthest place on the left, where the biggest place value of the number is. Okay? So I'm going to show you a series of numbers, and I want you to add them by looking at the first place on the left of these numbers and get a quick estimate of what these numbers are worth, or this whole set would be worth if we were to add them by looking at the first digit. Maybe we'll do this one a little slowly. You ready? Okay, I'll pause for a second. Okay, let's see how fast you can add these numbers. Who can give me an estimate based on the front first place value? Ready? You can say it. right? I heard it, 14. So the reason that I'm hearing 14 is people are looking at the first digit, which is the biggest place value. 3 plus 1 is 4, plus 1 is, plus 8 is 13, plus 1 is 14. So we have an idea that this front end estimation gives us a low estimate, right? It's something more than 14, we know that. Because we can quickly add the largest place values and we see 14. And then with front end estimation, we could take it a step further. We could say if the fronts are total up to 14, look at this 88, that's almost another one whole, right? And what about 46 and 32 together? Could that give us another whole? So there's 2, and then this doesn't really amount, so we could add at least 2. So the estimate would now become 16, okay? So we add the front ends, and then we could add the remaining quickly like that by just doing a quick rounding and have just a rough estimate of 16, which is probably a close estimate to the sum of these numbers. Okay, so jot that down.